Okay, so on the previous page, we looked at how graphs move up and down. And now I want to take a look at how graphs are going to move left and right. So we're going to use this same scenario of a heating schedule for a building. But what we're going to do is we're going to move everything 2 hours back in time. So originally we started heating the building at 4 a.m. Now we're going to heat it at 2 a.m. We're going to reach 70 degrees at 6 a.m. We'll start cooling off at 2 p.m. and then we'll be back at 50 degrees by 6 p.m. instead of 8. So everything is going to shift down by 2 hours. And we're going to go ahead and graph this. So we start out with, we're going to start to warm at 2 a.m. So here's where here's 2 a.m. Here's where we're going to start heating the building. So that by 6 a.m., we are up to that 70 degrees. So that's going to look like this. Okay, and then it says by 2 p.m. we're going to start cooling off. So 2 p.m. is 1400 hours. Goes here. And then it said by 6 p.m. we'll be back down to that 50 degrees. All right, so that is going to look like this. All right, so we've moved that graph over. All right, and down below you're going to see a familiar graph from the previous page, the 0.25x cubed. I've given you the standard graph with the table. And now what we're going to do is we're going to look at playing with the value of x. So before, we would just add something on the end of our equation. Now what we're going to do is we're going to change the inside part with x. So instead of it just being x cubed, it's going to be that whole quantity x minus 2 cubed, or this other graph is x plus 3 cubed. So I would encourage you to use your calculator. You can go ahead and put that function in there if you're doing a graphing calculator. And then when you look at these, you'll notice that the numbers are not the same here. So this one starts at -2, this one starts at 0, and this one starts at -5. And there's a reason for that. So if you're using your calculator, make sure you change your table to start at whatever value you need it to. So if it starts at 3, you put a 3 in there or whatever. So we need a 0. This column starts with a 0. And then that'll give us our table of values. We can certainly look at the graph and see what it does. All right, so go ahead and pause the video, give that a try, and see if you can come up with a conclusion to fill in these boxes down at the bottom. Okay. All right, so let's take a look at this and see if we got some of the same values. All right, so here are my two sets of tables. And let's see, kind of where my cubic function here crosses the x-axis is going to happen at x equals 2 here. It'll happen at x equals -3 here. So it looks like this graph, I moved it to the right some. And this graph here, if I compare it to my original, I moved it to the left some. All right, so let's talk about what kind of conclusions we can reach from that. So if that inside part with the x is a plus, like this graph over here, we're going to move to the left 2 units, or h units, sorry. And so whatever number that is. And then if it's f of x minus h, then we're going to move to the right h units. All right, so let's see if we can use that to figure out an equation for this graph that we worked on at the top with the temperature. All right, so we moved our graph to the left. This gray one is the original, this is the new one. So we went to the left, and we went to the left 2 units. So let me slide that down so you can see. All right, and so we're going to the left. We want to use this form here. And we went 2 units, so we'll replace the h with a 2. So we'll have f of x plus 2. Or in this case, I guess since we're using the letter t, we have f of t plus 2. Okay. All right, so I will see you back in the next video for some more practice with this.